It says here a proportion is an equation. So what does an equation mean? What word do you see almost as equation? What does it look like? Equal. So an equation is a math statement that has an equal sign. That's all an equation is. So a proportion has an equal sign, and it states that two ratios. So what was a ratio? Y'all remember? It's kind of like a fraction, right? Two fractions or rates are equivalent. So right here are what some proportions look like. If we said 1 over 2 is equal to 3 over 6, that's a proportion. Because a half is the same thing as 3/6, right? If you just reduce this fraction, you could see it's still 1/2. Okay, right here again, 8 feet per 10 seconds is equivalent to 4 feet per 5 seconds. So right here's what proportions look like in numbers. Now in algebra, when we don't have so many numbers, when we're dealing with letters, right, or variables, we could say a proportion is where A over B is equal to C over D. But we have to make this statement, B and D cannot be equal to 0. Why do we have to say that? What happens if B is equal to 0? Then 0 is on the bottom of a fraction. Are we ever allowed to put 0 in the denominator of a fraction? Never. So we say B cannot be 0 and D cannot be 0. Because that would make these fractions invalid. We can never have 0 on the bottom of a fraction. Now they show a little way that we can solve it. So again, what if we had A over B equals C over D? And we're dealing with an equation. So again, equation is something that is equal on both sides. If I tell you something's equal, it's like I've got a giant scale. You know those old school scales where you weigh stuff and whichever side's heavier goes down? Okay? Well, an equation, I'm telling you that I've got that scale and both these sides are equal. They're the same weight. Okay? That's what an equation means. That's the way I think about it. So if I start with this statement, A over B equals C over D. Now, what did they do here? They decided to multiply the left side by BD. Okay? We can talk about why they decided to do that later. But let's just pretend we don't care why they did it. So if you multiply the left side by BD, what happens to my scale? It's out of whack. Right? Only one side has been multiplied by BD. So what do I have to do to get it back in balance? You multiply the other side by the same thing. So if I multiply one side of my equation by BD, I have to multiply the other side of my equation by BD. And in math, that's valid. With equations, we can do whatever we want to an equation as long as we do it to both sides. Because if we do it to one and the other, it balances back out. So no, you can do any operation that you want as long as you do it to both sides of the equation. Now we can see what happens once they did that. When they multiplied by BD on the left, you see you had a common factor of B in the numerator and the denominator. So those went to 1, or you might have heard cancels, right? Have you ever heard cancels? Maybe not. Good, because I'm not going to say it. All right? These are common factors. So they simplify to be 1. And so we're left with A times D, which is AD. Over here on the right, when we multiply, they've got a common factor of D. So we can simplify those D's to be 1. And we're left with C times B, which is BC. So they did this little step here, multiplying by BD, and we were left with the statement AD equals BC. Now that's good because it's always true. So what we can gather from this is a shortcut. A way we can solve proportions. Does anybody remember what that shortcut is? When you have proportions. When you have fractions equal to fractions. No? Okay, well, here we go. You're going to hear me say this a lot because this is one of the things we deal with all the time. Anytime you have a fraction equal to a fraction, we can cross multiply and set them equal. So A times D is AD. B times C is BC, and we set those equal. So you see, they did it a very mathy way. They showed you multiplying by BD on both sides, and what we were left with. AD equals BC. I can show you the shortcut. A times D equals B times C. That's called cross multiplying. So again, this is called cross multiplying, and you're allowed to do it anytime you have a fraction equal to a fraction. So get used to that. If you ever see a fraction equal to a fraction, that's probably the way we're going to solve it. A carousel makes 4 complete turns after 64 seconds. At this rate, how long will it take the carousel to make 10 complete turns? So when I look there, my keyword is rate. Rate tells me that I'm going to be making a fraction. So what is the rate that I am given? I'm told that it makes 4 complete turns after 64 seconds. So that is my initial rate. 4 turns after 64 seconds. Now, what do I need to make sure I put? My units. It's going to help you so much, I promise, if you'll write those units down. So what is the number 4 representing? It's the number of turns that the carousel makes. So I'm going to put 4 turns over what 64 represent? The number of seconds. The number of seconds. Now, if we're going to continue at this same rate, because that's what it says, at this rate, that means my other fraction is going to be equal to this one. It's at the exact same rate. The only thing that's changing are the numbers. But when I divide the numbers, I should get the same thing it reduces to. So what do we know about this second rate? It tells me it makes 10 complete turns. So where would I put that in my second fraction? Where does the 10 turns go? How do you know it goes on top, or the numerator? Because turns is in the numerator of the left. Absolutely. So they have to match. If I've got turns in the numerator on the left, I need turns in the numerator on the right. And now how many seconds would that take? That's what we don't know. We don't know how many seconds it's going to be. It's our unknown. So what do we do in math when we don't know a value? We have to solve for it, but for right now I want to plug in a value for it, which is, I'm going to say X. Say it took X number of seconds. Now when I look, what do I have? I have a fraction equal to a fraction. I have a proportion. How can I always solve a fraction equal to a fraction? We can cross multiply and set those two values equal to each other. So what is 4 times X? It's 4X equals, what's 64 times 10? 640. Now, we're going to talk a little bit about solving this equation, about getting X by itself. You have done some of this before, but I've got a very specific way that I ask questions. So you'll get used to hearing me say this all year. So make sure you're listening. My goal is to get X by itself. So I ask myself a question. Why is the X not by itself? And the reason is it is being multiplied by 4. I want you to give the operation and the number. Don't just say because there's a 4 there, or don't just say because it's being multiplied. Okay? So again, I say, why is the X not by itself? Because it's being multiplied by 4. How do you undo multiplying by 4? by what number? Mm-mm. If I told you, think of your age right now. Think of your age. Now multiply that number by 4. We got it? Now how can I get back to your age? Divide that number by 4. Right? It completely undoes multiplying by 4. So right now, x is not by itself because it's being multiplied by 4. The way we undo that is dividing by 4. But now this is an equation. It's a giant scale. If I divide by 4 on one side of it, I'm out of whack. How do I get it back to balance? You have to divide the other side by 4 also. Now, 4x divided by 4. 4 divided by 4 is 1. So that leaves me with 1x, which is just x. 640 divided by 4 is 160. So now that I know x equals 160, that means my missing value is 160. It would take 160 seconds for the carousel to make 10 turns. Now let's look at the next problem. It says for every 18 people who have a sore throat, which is me because y'all making me do all the talking. I'm one of those 18. There are 2 people who actually have strep throat. If 72 patients have sore throats, how many of these would you expect to have strep throat? So we're kind of making a prediction here. We're wanting to take a ratio that we know and put it onto a larger situation. So again, we're trying to make a prediction. A place that I use this a lot, because again, I like basketball. Say that somebody makes 2 out of every 5 3-pointers they shoot. That's 40%, right? You're like, what? That's a good answer. Somebody told you to say that.
Yep, Becca did.
2 out of... If I make 2 3-pointers out of every 5 I shot, then how many could I expect to make if I shot 100? Right? Same idea. We're trying to predict something from a smaller sample size. So here, 18 people who have a sore throat, there are 2 that have a strep throat. So that is a rate. So what's that rate? What's that rate?
18 over 2.
That's fine. You can do it that way. So let's do 18 sore throats over... Oh, that's not going to work. They both are ST. So for 18 people that have sore throats, there are 2 that have strep throat. So again, write those units. It'll help you set it up correctly every time. Write them, write them, write them. Okay, so now my other rate.
72 sore throats.
So 72 sore throats, does that go in the numerator or the denominator?
Numerator.
Numerator, because they match. So I've got 72 sore, and I want to know how many will have strep. And so what do I put down there in the denominator?
X minus strep.
X strep. Questions about setting this up? Now what am I left with? A fraction equal to a fraction. How do we solve that? Cross multiply and set those 2 things equal. 18 times x is 18x. 72 times 2? 144. So now again, my goal is to get x by itself. Solve for x. It's not by itself because it's being multiplied by 18. How do we undo multiplying by 18?
Divide by 8.
Divide by 18. On both sides of the equation. Keeps it balanced. See how math is just a big game. You play the same game over and over and over. 18 divided by 18 is 1. 1 times x is x. What's 144 divided by 18? 8. So that tells me what? If 72 people come in with a sore throat, I would expect 8 of them to have strep throat. Any questions there?